in one of the videos in this playlist, we have shown that the sine of a certain IZ is equivalent to I times the hyperbolic function of sine Z. We have a video for that in this playlist. Please try to review that. This time, let's try to return the favor. Let's have the proof for the hyperbolic function of sine, but in this case, the angle is IZ, and it should be equivalent to I, a factor of I, times your sine Z. Okay, so that would be our task for this video. We're going to prove that. First, let's try to provide the equivalent form for the hyperbolic function of sine Z, and we have our sine Z as well, for us to be guided with our process. The hyperbolic function for sine Z is identified as e to the power of z minus e to the power of negative z over 2. Okay, that's for the hyperbolic function. But for the trigonometric function sine Z, it's actually e to the power of iz minus e to the power of negative iz over 2i. So we're doing this because our goal must be this one here. So it should have a factor of I as indicated here. Okay? So without canceling that, we must be able to show this form after we change the angle of our hyperbolic function into iz. That's our goal here. So let me erase all of this. Okay? And let's start with our proof here. So we would start with the sine or hyperbolic function of sine, but instead of z, we will have here iz. That means instead of z here, we're going to change it to iz and all the z's here as well. So this will be equivalent to e. Instead of z, it will become iz minus e to the power of negative iz over 2. Okay? That would be the form that we would like to determine. Now, for this to be true, we are just going to multiply the, remove the grouping symbol. We will have here the form e to the power of iz minus e to the power of negative iz all over 2. And when you look at the numerator, it's actually similar to our target already. Okay? But since our denominator is just 2, and this would be 2i, what would be done for it to become 2i as part of our goal? And take note that aside from that, we also need to find a factor of I. So what we can do here is, of course, this might be equivalent into a form e to the power of iz minus e to the power of minus iz over 2 when we try to multiply this with I over I, or simply equivalent to 1, and that means it's just the same, right? We're doing this because this is our we are proving. But of course, if we're solving the final form, a simplified form, we don't need to really write here I. But for the purpose of proving that we would like to reach this point with a factor of I, and again another factor of I, so we will have to do this. So simply multiplying only the denominator, you will have this form e to the power of iz, minus e to the power of negative I, that's a z, all over 2i. Then you will have here a certain factor of I, as you only have to multiply the denominator. Rearranging that, you will have here I times e to the power of iz minus e to the power of negative iz all over 2i. So that we can show now that when we start with the hyperbolic function of iz, we are yielding with I. And what is this equivalent to? That's actually, again, the trigonometric function for sine. That's actually I times sine z. We have shown that this identity is true using these processes. So basically, if you're trying to prove identities, you just simply need to manipulate it in such a way that your target will be possible. And with that, we multiplied it here just to arrive on our target. And that is actually the proof for this video. Thank you very much for watching.